All right, so today what we're going to do is we are going to be adding, subtracting, ordering, and comparing rational numbers. Now we've already done a little bit of this, but we're going to get into it just a little bit more. We're going to start off with comparing rational numbers. So here, we're going to take, and these are inequalities, less than, greater than, equal to, and we'll deal with more of those a little bit later. You've already seen them a little bit before. So to make 2/3 blank 5/6 a true sentence. So we're looking to say, okay, which one of these inequalities fits in here? That's what we're looking for. So method one, if they give you these two, they're going to say find a common denominator and then compare them that way. I don't personally care for this way if you have a calculator, but if you don't have a calculator, this is the way you're going to have to do it. So the least common denominator of 2/3 and 5/6 is 6. Well, how did they get that? Well, what they did was they came over here and they said, okay, 2/3 and 5/6, and they looked at the bottom two numbers and they said, I can either list the multiples of these numbers, so I could list 6, 12, 18, 24, and so on and so forth, and then list 3, 6, 9, so on and so forth in order to find those multiples, right? So it would look kind of like this. 18, and then you could keep going, right? Well, I always take the bigger number and I list it about 2 or 3 times, maybe 4, depends on how many there are. And then you list the other one. 3, 6, oh wait, look, 3 goes into 6. 3 and 6, look, you have it right here. That's your common denominator. That's what you're doing here in order to get your common denominator, all right? So now I have my common denominator. Well, what did I do to the 3 to get it to 6? Well, I multiplied it by 2, right? 3 times 2 gets me 6. So they come in here and they take this 2/3 and they multiply this denominator by 2. And then they come up here and in order to keep this fraction being the same fraction, right? It's got to be an equivalent fraction. So I've got to make sure multiply this top part by that same number. Because if I don't do that, it's no longer an equivalent fraction. Okay, so 2 times 2 is 4. 3 times 2 is 6. That's how they got this 4/6 right here. Now what they did was they said, well, I don't really do anything to 5/6, right? Because it's already got a denominator of 6, so I don't have to touch it. And then they came in here and they compared it. They said, well, 4/6 and 5/6, well, is 4/6 greater than 5/6? No. Is 4/6 less than 5/6? Yes. So that's the inequality that goes in there. And that's what they did here, right? And then they went back and they said, well, that's true. So if I come back to this original problem, 2/3 is less than 5/6. That's how they got this. All right? It looks complicated, but once you do a couple of these, it's not that big a deal. All right? The other way to do this is to turn them into decimals, which if you have a calculator, is the easier of the two methods, right? I just take 2/3 of 5/6, and we say, okay, well, in order to turn a fraction into decimal, I just divide 2, the numerator, divided by the denominator. 2 divided by 3, and that gets us this 0.6666667, this repeating 6, right? So you list it like this, 0.6, repeat, with a little bar with it. That little bar means that it's repeating. And then they did the same thing to the other one, 5/6 equals 0.83 with the 3 repeating. Notice they didn't put the bar over the 8, they just put it over the 3, because the 3 is the part that's repeating. All right, and then they said, well, 0.6 is less than 0.83, so therefore 2/3 must be less than 5/6. This is the easier way. If you got a calculator, do this. But if you don't, you need to know that other method. You got to be able to do that. So that's the easiest way to compare fractions. Those are the two ways to do it. And then come down here and you order. Oh, let's skip one. No, I didn't. Order rational numbers. Now we've already done this once before, but turn them into decimals, put them in order from least to greatest or greatest to least, whatever they ask for. Here they're asking least to greatest. Make sure you read and check to make sure you're putting them in the right order. But just turn them into decimals. That's all you gotta do. Well, we just did that. Just divide the numerator by the denominator. Okay? If you're doing it on a calculator, top number goes in first, divided by the bottom number. Make sure you can do that. And then go from there. Alright? So comparing, ordering, not that big a deal. Should be able to do it. And then, then we have adding and subtracting like fractions. Okay, so we dealt with ordering and comparing. Okay, turn them into decimals, see which one's bigger. Comparing, turn them into decimals, put them in order. Or you can find the common denominator if you're doing comparing. All right. Now we're going to talk about adding and subtracting fractions. Now a like fraction has the same denominator, is what you're looking at. So if it has the same denominator, you're just following your sign rules with the numerator. You're going to keep the denominator and you're going to add the top number, the numerator. Or if you're subtracting, you're going to keep the bottom number and you're going to subtract them. Just like this, look, 3/5 plus 1/5. You're going to keep the denominator, 3 plus 1 is 4, you get 4/5. It really is that simple. If you have a common denominator. That's the key there, okay? Now you're subtracting, 7 over 16 minus 1, 16. Common denominator, we're good. 7 minus 1 over 16, well, 7 minus 1, 6 over 16, but you always have to simplify. Make sure you reduce your answer. Make sure you do that. So what did they do here to reduce this? They divided by 2. They divided the top and the bottom by the same number in order to reduce it. Okay? So you got 3/8. And you're going to have whole numbers here in order to do that. That's what you're going to have. Okay? If you get decimals when you reduce, you got something wrong. Don't use decimals. You want whole numbers. All right. So coming down to the next, 4/9 minus 7/9. Same denominator. Same thing, 4 minus 7 over 9. Use your sign rules. 4 minus 7, add its additive inverse. So 4 plus -7, then subtract, keep the sign of the bigger number, right? We go right back into our addition sign rules. So we get 3 over 9, -3 over 9. Gets you 1/3, you simplify. At this point, you should already know how to simplify a fraction. So minus 1/3. All right, move on. When you don't have a common denominator, this is where you got to go back and get a common denominator. Kind of like when we were comparing the fractions a second ago, we need a common denominator. So we're going to check. The easiest way to get a common denominator, it won't always be the least common denominator, is to multiply the two denominators together and it will guarantee you to get a common denominator. Works every time, but it won't necessarily be the least common denominator. If you don't get the least common denominator, you're gonna have to reduce at the end, guaranteed, okay? But it works every time if you need that method. The other way is to look and list the multiples. 3, 6, 9, 12, so on and so forth. 2, 4, 6, 8, 10, so on and so forth. So when you're looking at something like this, you know what your common denominator is. It's going to be 6. So they're going to multiply 2 times 3 and 1 times 3 in order to get that to be an equivalent fraction. Remember, you have to have an equivalent fraction at the end. Otherwise, you're not actually adding what they're asking you to add together. So you get 3/6 plus 4/6, and now you're back into what they gave you here. Now, notice here, you end up with this mixed number or, I forgot what it's called. Improper fraction, that's what it is, improper fraction. 7/6, lost that for a second. So you have this improper fraction, guys. If you're giving me a number, the improper fraction is good enough. I know that they're the same thing. This is the usable version this is not really usable. Especially in algebra, which this video is for, it's a real quick video review and stuff. You leave it in the improper form. We're gonna use that. We can't use this. Everything's gonna get turned into that improper. All right, so keep moving. 3/8 minus 1/3. Again, you need a common denominator. When you multiply it, 8 times 3 is 24. 3 times 3 is 9. That's how they get this. 3 times 8, 24. 8 times 1, 8. So you got 9 over 24 minus 8 over 24. 9 minus 8 gets you 1, and it's over 24. This is not that complicated, just don't overcomplicate it. Okay? Now, I'm going to come back to some, no, you know what, we're going to work with the fractions now. So we're going to come over here and we're going to deal with the fractions. We'll come back over there in a minute to deal with the decimals. Decimals are easy though, so it won't be that big a deal. All right, so we have some different fractions, and I put these up here because these are a little bit harder than what we actually had to deal with there, but they're not crazy hard. Okay? All right, you have 1/6 plus 3/8. You need a common denominator. Now, you can take and multiply these two things together and you'll get a common denominator every time. But what I suggest is you take the larger of the two denominators and you list out the multiples until you get one that this one divides into. Okay? So that's what you're looking for. So 8, 16, 24. Oh, wait. Can't you multiply a number times 6 to get 24? Okay. Well, now I have that, right? So how many times did it go here? 3. So 8 times 3 times 3. And what can I multiply times 6 to get 24? Well, 4. So I have 4 over 24 plus 9 over 24. And now I get to add the top numbers together, the numerators. I just add the numerators together. And then I have my answer. 9, 10, 11, 12, 13. 13 over 24. That doesn't reduce. That's my answer. Yes. If I did it the other way, I would have had to reduce my number, and I was still ended up here. Okay, so make sure you can do this. All right, so here we got 5/6 minus 9 over 16. I'm going to list that 16 out. 16, 32, 48. Wait, I know that 6 can be multiplied by something to get 48. Okay, so I multiplied this times 3, this times 3, 6 times 8 gets me 48. So I'm going to multiply this times 8. Now I'm doing the top by the same number to make sure I keep the equivalent fraction. So here we got 40 over 48 minus 27 over 48. So going to subtract 40. So I don't remember what that is. 3, 2, so 3. 13. Make sure I write that clearly so you can see it. Okay, so I've got 13 over 48, and because this 40 is larger than this 27, I know this is a positive number. Okay, that's all it is. And if you wanted to see it, what it is this. That's how they show it. Okay, just so that you can see what's going on there. So that's all I did right there. I did that. I did this math right there so that you can see it. That's what it is. 13 over 48 doesn't reduce. We're good to go. Now we're going to move on. 6 over 12 plus 9 over 15. Now, you could list out 15, but look at your numbers. 6 over 12, that reduces. But these bottom numbers are really large. You want to deal with that? 6 over 12 reduces. It reduces to actually a nice clean number too. 1/2. Right? Because isn't 6 half of 12? And then 9 over 15 actually reduces too. 3 goes into both the 9 and the 15. So I can actually divide by 3, divide by 3. Here, I'm dividing by 6, divide by 6, just so you can see what we did there. Okay, so I got 1/2 plus 3/5. Isn't that much easier to deal with than this? So check and make sure before you actually just start listing these out. Hey, does that reduce? Because it might be easier to deal with. All right, so I got 1/2 plus 3/5, much easier. I know my common denominator is 10. I can multiply this by 5, this by 5, this by 2, this by 2, and now I'm going to get a common denominator. So I've got 5/10 plus 6/10. And now I'm going to add those together. I get 11/10. And like I said before, improper fraction is good for me. This works, 11/10. Okay? Now you could write it as a mixed number, but this is usable, the other's not. So leave it here. Other teachers may tell you differently. Do what they tell you. I tell you to do this. Okay? Now, come down here. 8/12 minus 1/8, 18th. Okay? Look here, 8/12. Doesn't that reduce? Now I could list this out, and I'd get there. I just have to reduce at the end. But here, 8/12 becomes, let's see here, divide by 4, divide by 4, 2/3, 2/3 minus 1/18. And now look, doesn't 3 go into 18? All right, so times 6 gets me 12/18 minus 1/18. And now all I gotta do is subtract the top. 12 minus 1 gets me 11/18. And I end up here, 11/18. And these fractions aren't near as hard as you make them out to be. Don't overcomplicate them. All right. One last one. 1/12 plus 1/18. Again, I'm going to list out. Notice I can't reduce these, so I have to deal with these numbers. So, all right. 18/36. And I could keep going if I had to, but doesn't 12 go into 36? So I'm going to multiply this by 2, this by 2, this by 3, this by 3. And guys, I get it. When you do these, you may have to use a calculator on some of these because you may not have them memorized. It's okay. All right. So 3/36 plus 2/36. Add the top. 5/36. There's your answer. Guys, make sure you circle your answers. I didn't. Or when you turn it in, make sure you circle them. Your teacher appreciates it. Okay. All right, so one last, a few other things. We got decimals that we need to go through. Again, just like the fractions, this is a review. You should know how to do this, but we're just clarifying it, getting you to remember how to do these things. Let's deal with some fractions. All right, so here, use a number line to find 2.5 plus negative 3.5. Don't use a number line, guys. You already understand this concept, or at least you should at this point. Take them, line up the decimals, right? So, in order to add two numbers, really what you're doing is subtracting them, but you're going to do this. 3.5, 2.5, and you're adding the negative together, right? You're adding its inverse. All right, so 3.5 plus, or negative 3.5 plus 2.5, you're going to subtract, keep the sign of the bigger number is what you're doing here. Okay, so subtract 0, bring down your decimal, 3 minus 2 is 1. This one's bigger than this one, there's your answer. It's the same thing they did. Okay? Not complicated, but when you're dealing with the decimals, you've got to line them up. When you're adding or subtracting decimals, you line up the decimals. That's not true when you're dealing with multiplication or division. It is true when you're dealing with addition and subtraction. So make sure when you're doing addition and subtraction, you're lining up those decimals. All right. So here, they show you this way, don't do this. That's confusing, don't do it. Okay, so what we're gonna do is we're gonna come over here. Negative 13.12 plus negative 8.6. The signs are the same, so all we gotta do is add them together and keep their sign. Okay, sign rules, know your sign rules. So 13.12 and 8.6. Notice, I lined up the decimals. I already know this answer is negative because I got two negatives that I'm adding together. So I just put the negative down there so I know it's there. Now here, if you like, you can add in this 0 here. Right? No big deal. Add it in there. Okay? 2, 6 plus 1, 7. Bring down your decimal. 8, 9, 10, 11. Bring up your 1. 21, negative 21.72. It's the exact same thing they got. But this is a lot easier and a lot cleaner than what they were trying to show you. All right? Don't overcomplicate it, all right? So no big deal there. And then, looks like they jump back into fractions, but guys, that's pretty much it for the decimals, I believe. Let me check real quick, make sure I didn't miss anything. Nope, that's it. Okay, hey, if you need any help with this stuff, you're just a little bit behind on it, you're a little bit confused with something, come see me, I'll help you get help.